Hey, what's up, guys? In this video, we're going to compute limits using the squeeze, yeah, theorem, or also called sandwich theorem, right? We started here with the first example. We're having the limits when x goes to the infinity or approaches the infinity of the sine of x divided by x. We know that when we were working on the sine, finding the domain and the range of the sine, we said that the domain of a sine was, still is, from minus infinity unto plus infinity. Okay, and this is of course the x value. So that's where we read the domain of the sine. This is about the x values, right? And now in the range, let me put r like I did before of the function or something like that. The range of this function as the x value approaches infinity on both sides, either on the left or the right, minus or positive. The range was from -1 to 1. Okay, and this is of course about the y values. So it means that we have in a sine function, remember sine function here going through 0 under something like that, right? Okay, and power 2 here, pi and everything. Okay, this is a sine function. This is, you can see the domain of this function is all about, we're talking about the x-axis. It's covering the whole x-axis. It is minus infinity to plus infinity. But as this function tends, or as the value of this function tending to the infinity, what is the value of the y-axis? Of course, the value of the y-axis are -1 and 1, and this is here the range of the function. So we know that this function sine of x, okay, is in between -1 and 1. So now we're simply going to consider our range here to find the limit of this fraction here, including with the sign, right? So we're going to say -1, we're going to say -1, this one here, -1 less than equals to the sine of x. That's what we know already. That's what we have here, the sine of x, less than equals to 1, okay, in this range. And now if we divide the whole, this whole inequality by x, we will have -1 over x less than the sine of x over x, and this is actually our function right here, less than 1 over x, right? And as you can see, we know it already. If x tends to or approaches the infinity, the denominator here on the outside, the denominator of these two outside value will be 10, will be, it's going to go greater, and as it get greater, the whole fraction will get smaller and smaller and tending to 0, and we know this is really actually going to tend to 0. This one also tending to 0. And by using the squeeze theorem or sandwich theorem, of course, we know that if the limit of the outside function are equal, that of course the limit of the inside action will take the value of those outside function. So we would just say that it's like, this is kind of a conclusion, right? Say this function here, I change color here. Okay, the limit of these two functions are tending to 0. So we're gonna say the limit, therefore, the limits when x approaches infinity of sine of x over x is also equal to 0, right? And this is what the squeeze theorem stipulates or says, right? And we're having this function in between tending to 0. So about this second example now, if you watch my previous video, my video about sine to the power 2, domain and range and everything, you would have seen that the domain of this function sorry, we know the domain of the sine function. That's what we got there already. The domain of the sine function was, still is minus infinity to, oh sorry, to plus infinity. And but the range of sine to the power 2 was remaining positive, because no matter what value you give x in this case, okay, sine to the power 2 was going to be squared and be positive. So we were having 0, the range from 0 to 1. And this is what we're going to use to find the limit of this function right here. So we would just say that we're having, if we know that 0 is less than the sine to the power 2 of x less than 1. So we can say, we will add 2 on it. Then we say 2 plus 0 is less than 2 plus sine to the power 2 of x. That's less than equal than 2 plus 1, right? So you can see we're having here 2 less than equal than 2 plus sine to the power 2 of x less than equal to 3, right? We still have to multiply the x to the power 2 on it. So we're going to have on this side here 2x to the power 2 less than x to the power 2 times 2 plus sine to the power 2, or sine squared of x, and less than equals than 3x to the power of 2. And we're going to divide by x plus 10 now. So we're going to have here divided by x plus 10, and then we're having the same thing here divided by x plus 10, and having the same thing here divided by x plus 10. So as you can see here, the two outside functions are only normal, quadratic quotient function. And that's what we did before. And to take the derivative of, to find the limit, or to take the limit of this kind of function term, type of function, it's very simple. We can say, if you're doing, proceeding on this side here, we will say that the limit of when x tends to the approach to infinity of 2x to the power 2 over x plus 10, right? We will just factor, the largest power of x here, and that's it. So this is going to give us the limits when x tends to the infinity of x to the power 2, or maybe x times 2x, factor and cancel, x times 1. If you factor x here, it will remain 1 plus 10 over x. And, it's actually 100. What am I doing? It's 100 here, 100 there, and 100 there, and 100 there. Okay, not bad. We have it. 100 over x. Alright, and as we've seen here, of course this is going to tend to 0, and then we're going to cancel. This is tending to 0, and we're going to cancel the x. So, and you see, we still have is the limit when x approaches the infinity of 2x. And this is definitely, when you plot infinity here, the whole thing goes to the infinity. This is the infinity. And by so we're having now, these are the outside function equal to infinity, tends to infinity, and consequently, by the squeeze theorem, we will say that these are the one tends to the infinity, right? And of course, the limit of the function, the inside function, will be tending to infinity. So we will say this here, the limit, this mean here, the limit of this other function, x to the infinity. I don't need to write that because it really doesn't mean, but it is a separate thing. So we will say that according to to the squeeze theorem, ST, right? According to the ST, limit when x approaches to infinity of 3x to the power 2 over x plus 100 is also infinity, right? That's what we have. And going further with the squeeze theorem, we will only say that the limits, because this is a consequence here, right? This is a therefore. It follows. So because we have the two outside function having the limit infinity. Infinity is actually not a limit. We can say that it doesn't exist, but we don't know what infinity is. So they're having infinity anyway, and therefore what we're going to consider is that by using the the squeeze theorem, we're going to say consequently that the limit of this function tends also to the infinity, right? So that's what we're going to have here. X tends to the infinity. Oh, I got an x here, not n. Okay, x to the power 2 times 2 plus the sine squared of x over x plus 100 also tends to the infinity, and that's what we can say about that, right? And as you can see right here, the squeeze theorem is all about the outside function, right, on both sides. If you can take the limits of the outside function, consequently you'll be having the limits of the inside function, and that is what the squeeze theorem is all about. Okay. In other words, the outside functions define what the inside function can be or could be.